Oh, hello. Greetings, Math 96 students. This is your Professor Cody from home in my apartment. I apologize again for the late cancellation of class this morning because I was not feeling well. I'm not feeling well. I'm hoping, though, that I'll be back tomorrow. I went to see the doctor this morning and hopefully he's got me on track. So as promised, this is a video to help you complete the assignment from lesson 4.2. Remember, it is extra credit. If you can do the problems on page 154 and bring them to class tomorrow, I'll give you some extra credit for that. Also, it's intended to help you be successful on the homework, as well as a quiz you have later this week on that lesson. So that should be helpful. Now, I know the thing that you all are most concerned about is not getting your daily meme and announcements for today, but don't you worry, I've got you covered on that. So here they are for you. So you'll notice there's lots of important things on there. This is also posted on WAMAP if you're having trouble reading it through the video, so you can get a copy of it there. A couple of things I want to point out to you. Number one, you have a prep assignment due tonight by 11:59 p.m. We'll be doing 4.3 tomorrow, so please finish the prep for that lesson tonight. Also, as I mentioned, we'll have a quiz on Wednesday over lessons 4.1 and 4.2, so please start preparing for that now. I am working on grading your Module 3 exams. I apologize, they're not finished yet. Give me a break. I was sick all weekend. But I do hope to have them done by Wednesday and obviously Thursday at the latest. Okay, so let's go ahead and get started with the stuff we need to learn so that we'll be ready for lesson 4.2. And so I'm looking on page 153 for the stuff I'm about to talk about, so if you want to reference that in your book, you can. Now, in order to begin, we need to review a formula that we learned on Friday from lesson 4.1 about how to find the amount of money you have in an account after a certain amount of years if you have an interest rate that is compounded yearly or annually. Now, if you guys look at your notes, do you remember what that formula is? Go ahead and look. I'll wait. Okay, so what's that formula? Very good. It is A equals P times 1 plus R to the tth power, right? So in this case, remember that P stands for our principal or our starting value. R is our interest rate, and remember that needs to be in the form of a decimal. And then T is the number of years. And it turns out we can use this formula to model what is called exponential growth in general. So anytime we have anything that is growing according to a percentage, this formula can help us to model that. So in that case, if we're using this in general, the value P then always stands for our starting amount or our starting value. Okay, R is what we call our growth rate. Okay, and remember that when you put in the value for R, it needs to be done as a decimal. So as an example of that, if I tell you that something is growing at a rate of 3%, well, you're not going to plug in 3 for R, you'll plug in 0.03 since that's the value of 3% as a decimal. Now, also we have that the value T in this case will be the amount of time. Generally, the amount of time is a number of years, but really what matters here is that the amount of time matches the amount of time associated with your growth rate. So for example, if I'm talking about something growing at a growth rate of 3% per year, then my units on T will be years. If I'm talking about something growing at a rate of 3% per month, then my amount of time is modeled with months then. Okay? Does that make sense? Excellent. Okay, so let's take a look at the problem on page 154 if you read along with me. So it says that depreciation is a process of losing value, opposite to that of accruing interest. For example, new automobiles lose 15 to 20% of their value each year for the first few years you own them. So then the question says, based on this fact, develop a depreciated value, D, formula for a $26,000 automobile based on 15% depreciation per year. And they give us a table there to help guide our calculations. Now, I want us to think about how this formula we have here relates to this problem. They tell us that the car is losing 15% per year, and the key here is that it's losing 15% per year. So if you think about this growth rate, if the value of the car is going down, what should be true about our growth rate here? Correct. It should be negative, okay? So here we are told in the problem that the car is losing 15% of its value per year. So I know then that my value for R, well, I got to convert that 15% into a decimal, so I know that'll be 0.15, right? But because the value is going down, that needs to be negative. So we have negative 0.15 for our value for R. Now, which of the other values here in the problem have they given us to begin? A, P, R, or T? Correct again, they've given us the value for P, right? They told us the starting value for the car, which in this case is $26,000. Okay. Let's see, is there anything else we know at this point? No, I think this will allow us then to write a formula that we can use then to calculate the value of the car after certain amounts of time. So using my formula up here, I have that in this case A equals P, which is my starting value, 26,000 times 1 plus the value for R, but in this case it's a minus 0.15, so I'm going to subtract 0.15, and they haven't given us any values for T, so I'm just going to leave that as T for right now. If I simplify this, then I have A equals 26,000, 1 minus 0.15 is 0.85 T. Okay, hopefully you'll notice that what this allows us to do now is to put in values for T and figure out the value of the car after a certain amount of time. So if we look at our table now, let's go ahead and do the first one together. So we're asked to figure out the value of the car when it is 1 year old. And they give us a spot to put our calculation and a spot to put the value. So I'm going to try to do that here on my whiteboard. So I'm doing for 1 year old. Okay. Well, my calculation is going to be to plug in 1 for the value of T. A equals 26,000 times 0.85 to the first. We'll go ahead and plug that into our calculator. So 26,000 times 0.85 raised to the first. And according to my calculator, then the value of the car after 1 year is $22,100. Okay, I apologize that the pen's a little fat, so it might be hard to read. Okay, cool. Any questions on that? I can't really hear your questions, can I? That's funny. Okay, so what I want us to do is let's take a few more minutes and fill out the rest of the table there. So go figure out the value of the car after 2 years, after 5 years, and then that final row there we've actually already figured out for T years would be our formula here. Okay, so take a couple minutes and do that. Okay, have you finished? If not, you can go ahead and pause the video and finish before I give the answers. But let me double check my work with yours. So I got that after 2 years, okay, the value of the car would be $18,785. And then after 5 years, the value of the car would be $11,536.34. Okay. And then again, as I said, for t years, that's where this formula comes in right here that we found. So the a equals 26,000 times 0.85 to the t. Cool? All right, if you missed any of that, you might want to back up in the video and maybe go through it one more time to make sure you got what I was talking about. Now, there are two more things I want to make you guys aware of in order to help you with the problems on the next page. So I'm going to go ahead and erase this and then explain what that is. Okay, so on the next page, they're going to ask you to do some comparisons between things that grow at an exponential rate, which is what we just did, or I should say grow or decrease at an exponential rate, versus things that grow or decrease at a linear rate, which is the stuff we talked about last module. Now, they're going to do this in a way that's a little bit different from what we did. They're going to connect this back to absolute and relative change. Now, if you remember, for absolute change, how do we calculate that? Good. Yes, it's the new minus the old value, right? So that's our absolute change. And then our relative change calculated using our absolute change. Do you guys remember how we do that? Good. Yes, it's absolute change divided by an old value. And again, I apologize, this is smushed in, but this is absolute change divided by old value. Okay, so on the next page, they're going to have you calculate an absolute change for something and a relative change for something. Now, if you remember, absolute change tells us the amount something is changing by, whereas relative change tells us the percent it is changing by. Now, if you think about it, first of all, that percent hopefully sounds like it's connected to exponential change, right, that we were just talking about. When we're looking at exponential change, something is changing by a percentage. Absolute change actually relates to linear growth or decay. Okay, and let me explain why that is. Because when something is changing at a linear rate, it is changing by an amount every time period. Okay, if you think about, there was a problem on your exam that talked about the amount of money that the movie Rogue One was earning every week. That was an amount it was earning every week. So that was a linear rate of change. Okay, and once we have that, you can use that along with a starting value to write an equation to model how something is growing at a linear rate. With the relative change, once we have our starting value and our percentage change, which we get from the relative change, then we can use that to write an exponential model. Okay, does that make sense? Great. If you guys have any questions as you're working on page 154, feel free to reach out to me via email or WhatsApp message. I should be available. I hope you guys all have a wonderful day, and I look forward to seeing you back in class tomorrow. Okay, bye.